Okay, so let us start this video with the graph of x square versus x. So here I have my graph of x square versus x. Yeah, so this is the graph of x square versus x, which means when I am at x equals 1 here, if I'm at x equals 1, the output here or the y value is also 1. And at 2, I get a value of 4. At 3, 9, so on and so forth. Now, if I have to plot a derivative function of this thing, so I need to first of all find the derivative at various points. So let's start by taking the most easy point, which is x equals 0. Okay, so at this point you can clearly see if I draw a tangent at this point, the tangent will be itself overlapping on the x-axis. So this will be my tangent here. Okay, like this. And such a tangent will have a slope of 0, obviously, because it is parallel to the x-axis. So therefore, if I come here and quickly plot another graph, okay, and this time I am plotting again on this axis I am plotting x, but on this axis I'll be plotting the derivative or the slope of the tangent, okay, at various points, which means dy by dx. Okay, so that represents my slope. So at x equals 0, the slope I just showed you is 0. Therefore I again at x equals 0 I plot here a point 0. Okay, that's the first point. Now let us take another point in this graph. Let's say I take it at x equals 1. Here I draw a, so here if I draw again, if I draw my tangent and find the slope, I will get the derivative at that point. Okay, but okay, yeah. So how do I find the numeric value of that? Well, I know this is the graph of x square, and if we differentiate x square, so if I have a function y equals x square, using the power rule, I can find the derivative of this thing. So if I use the power rule, I get dy by dx equals, so I can simply use the power rule, get the power at the coefficients place. So I have made a video on this also on the same, so I have it on the same channel. You can watch the video on power rule of derivatives, and you will, if you are getting confused in this, okay, so yeah, I get it at the position of the coefficient and reduce the power by 1. So 2 minus 1 is 1, so I get 2x. Yeah, so which means that if when I'm finding the derivative at x equals 1, the slope will be 2 times that, so 2x. If at x equals 1, so at x equals 1 I'll simply double that x value. So if I have x equals 1, the slope at this point will be 2 times 1, which is 2. So the slope at this point will be 2. So here at I come to this graph at x equals 1, I plotted, so this is 1, that's 2. Okay, so I plot, so that's 1 2. Okay, so at 2 I plot a point. Okay, so when x equals 1, the slope will be 2, so I'm plotting the value. Okay, here the value of the slope of the tangents drawn at various points. I can do the same thing at let's say x equals 2. Here thus if I draw a tangent at this point at x equals 2, the slope of this tangent will be again double of the x value. That is what this is saying here. So 2 times 2 gives me 4. So at um, x equals 2 here, I get a value, or I get a slope of, so that's 3, that's 4. So I get a slope of 4. So I plot at 2 I plot I plot this point, which is 2 comma 4, right? So I get the second point there. And I can do the same thing for the next point at x equals 3. I'll do it quickly for this point also. And yeah, at this point if I draw a tangent, this tangent, the slope of this tangent will be twice of this. So 2 times 3 is 6. So the slope of this tangent is 6. So I can plot that also here. At 3 I get a, so 4 5 6. So I get a slope value of the slope will be 6. So I get a point there. I think that's sufficient. So you could continue the same process for other numbers also, other values of x, but I think I'll stop at 3. And as you can see here, I've got 4 points. Okay, so I can simply join those 4 points by making a straight line. Okay, And if you can see, so when I join the 4 points, I get a straight line, okay, because they're collinear points. And that clearly, okay, so that is straight line, okay, wait, yeah. And that this line clearly is itself the line 2x, right? And that is obvious because after all I'm plotting all the values, so after all I'm plotting 2x itself here, so it is obvious that I'll get the graph of 2x here. And so this here is my original function, which is y equals 2x, or y equals x square. And when I plot the slopes of the tangents at various points on another graph, I get the derivative function. Okay, so this here is the derivative function which is being plotted here, and this is my original function which is being plotted, which I just plotted here. Okay, so this is my original function, this is the derivative function. Okay, so yeah, you should practice drawing such derivative functions, as they'll help you get a better as they help you get a better grasp on the concept of derivatives. Okay, so that's it, that is it for this video. We'll continue the same in the next we'll continue this topic in the next video also. So bye.